Hi, this is Jim Corkins again, and we are finishing our last part in the module about vectors. Okay, if you haven't done the reading, please do so. Those readings are indicated in Canvas. Now, this part, 2.3, is cross products and dot products. There are two types of multiplications when it comes to vectors. One is a cross product and one is a dot product. And they both do different things depending on the parts of the vectors that you're multiplying. Okay, let's start with dot products. Dot products are when you create a scalar component of another vector by multiplying the parallel portions of two other vectors. Okay, so suppose you had a vector A which had x, y, and z components, and so three-dimensional components, and we had another vector B which had x, y, and z components of B. Now, if you try to multiply these two vectors together using a dot product, see the little dot right there, then what you have to do is you have to take the parallel components of those vectors and multiply them together and then add them to the other components. So for example, A dot B would be the x direction component of vector A multiplied by B plus the y direction components of A and B, and then finally the z directions of components of A and B. And then when you add them together, they will be the scalar component of a new vector. So you'll know the size of that new vector. You don't know its direction. Okay, but you can figure out its direction using this cosine. So another way of doing this, so if you didn't know those components, you just knew there were two vectors, and let's say one vector is this vector, and you knew it was 4 long, okay? And you had another vector which was 3. That doesn't look like 3. Let's make it a little bit longer. Let's call this 5. All right. And you wanted to figure out its direction. The best way to start is figuring out the angles in between them. Okay. And so, to figure out this angle in between them, what we would do is we would take 4 times 5 times 5. Okay. And if you knew the components, the x direction and y direction components, you could just find the sizes of those vectors using Pythagorean's theorem. And then you have cosine of theta. Now, if you did know those components and we got another component which was c, and you knew the size of c, and that was, 15. Right? The size of c, which would be 15. I don't know if this is going to work out, but what we would do is take 15 and divide it by 4 times 5. And then set it equal to cosine of theta. And from there, we could take the inverse cosine of both sides and figure out what theta is. Okay? So we'll practice that. We'll practice both of those things, but first off, let's just make sure we understand what a dot product actually is. Okay, so over here, there are 4 vectors, A, B, C, and D. And A is pointing straight up. So its actual components of the vector, it will be 0i plus 4j. The B vector is pointing to the right 3 and up 3. So that'll be positive 3i in the x direction and positive 3j in the y direction. The vector C is only pointing to the right two boxes, so its components will be positive 2i but 0j. Finally, you have vector D, which is pointing to the left 3, which is going to be negative 3i, and up 1, positive 1j. Now, if we had to multiply A times C, well, A is perpendicular to C. And dot products need to take parallel, only multiply parallel portions of vectors. So since A is not parallel to C, no portions of those two vectors are parallel to C, like no x direction, y direction, then we know it's going to be 0. But mathematically what we're doing is we're taking the x direction component of A and multiplying it by the x direction component of C. Since A has no x direction component, that will be 0, and C is 2, 0 times positive 2. And since the y direction component of A is positive 4, and the y direction of component C is 0, that is going to be equal to 0, right? Or you could just say A has no parallel portion to C, so that is going to be 0. All right, now with B, you have this. If you take B and break it down, B is pointing up by positive 3, and that's really the y component of B. And B has an x direction component that is positive 3. So what we could do is we could multiply the x direction components of against A and the y components of B against A. And if you look right now, we could see that A is pointing up, so this is going to be positive 4j, and this guy is positive 3j, and this is positive 3i. So the only two parallel components of A and B is the by component and the ay component, which is positive 3 times positive 4. So our answer should be 12. But if you want to do it the mathy way, you got to take the x direction component of A, which is 0, and multiply it by the x direction component of B, which is positive 3. And then we're going to take the y component of A and the y component of B. So that's positive 4 times positive 3, which will be positive 12. Now, multiplying B times C, well, again, the only two portions that are parallel to each other are the x direction portions of B and C. So since C is pointing to the right, so Cx is going to be equal to positive 2, and that's in the I hat. Well, the two parallel components are C and Bx, Cx and Bx, which is positive 2 times positive 3, so the answer should be positive 6. But the math-wise, you take the x direction components of those, which will be 6. The y direction component will be positive 3j times 0 for the c vector. So that'll be 0. Again, for the b times d, well, the d vector is pointing to the right 3. So dx is going to equal to, I'm pointing to the left, sorry about that, it's pointing to the left 3, and it's pointing up by 1. So dy is going to be equal to positive 1j. Okay, so the parallel components of B and D, well, the x direction components are parallel, so that'll be negative 3 times positive 3, which will be positive 9. And then we have to add it to the other parallel components, which would be the j components, which will be positive 3 times positive 1. So our answer should be negative 9 plus 3, which will be negative 6. Let's see if it works. So bx dx is 3 times negative 3 plus by dy, which will be positive 3 times positive 1, negative 6. Okay. Now, what I want you to do is apply what you've learned to this situation. Okay. You have these two vectors indicated in the graph, A and B. what I want you to do is, we're going to do this in parts. I want you to figure out the unit vectors of A and B. And then what I want you to do is I want you to figure out what the dot product of A and B are going to be. Okay? So let's see if you could do both of those things. So figure out the unit vectors of A and B and write them here, and figure out the dot products of A and B, the dot product of A times B, and you'll find that answer. We'll do this next. Okay? So try those two things, creating the unit vectors and the dot product right now. Pause the video now. Okay, well, the unit vector of A, it has, let me switch this to red. It's pointed to the right 2, and it's pointing up 3. So we know A is going to be positive 2i plus 3j. And the B vector, its components, are going to be positive 4 in the x direction and up 1 in the y direction. So its components are going to be positive 4i plus 1j. Okay? Hopefully you did well on that. Now, if doing this next part, it should be pretty easy. You could do it with the vectors, or you could do it mathy. Let's do both. So if we want the dot product, you have to multiply the parallel portions. Well, A in the x direction is positive 2, and B is positive 4, right? So that's going to be positive 2 times positive 4, right? So that's going to be equal to positive 8. So the x direction portions are positive 8. I don't like the way that 2 looks. In the y direction, well, the y direction, we've got A is pointing up 3, and B is pointing up 1. So times positive 1. So we know the y direction should be positive 3. So then add these two guys together, and we should get positive 11. Okay. Math-wise, if you want to just follow the equations, we would do what we just did with the vectors, multiply ax times bx, and add it to ay times by. In which case you do get positive 11. Okay? Now that we know that whatever vector got created out of this, and let's call this vector r's magnitude. So we know the dot product of vector A dot B is going to be equal to, we know that's going to be equal to positive 11. Okay, well actually I should just say 11 since we're talking about magnitude. So what I want you to do is figure out the size of A, figure out the size of B, and since we have the size of the new vector by the dot product, I want you to figure out the angle between A and B. So I'm going to erase all of our lovely vector work that we just did. Thank you very much. Just kidding. So I'm going to delete this. So what I'm asking you to do is find out what this angle is in between A and B. What is theta? Right there. Okay? So try this out. Pause the video now. Okay. Well, first thing we need to do is we need to figure out the size of A. So what we're going to do is we're going to apply Pythagorean's theorem. We're going to go ax squared plus ay squared square rooted. And then we're going to figure out the size of B. We're going to apply Pythagorean's theorem to B, which is going to be bx squared plus by squared square rooted, and then multiply it by c. So now what we have is positive 2 squared plus positive 3 squared times positive 4 squared times positive 1 squared. Okay, so that is going to be equal to 3.6 when you square root it, and 3.87. Okay, which multiplying those two numbers together is 13.94. And we know that A dot B from up here is equal to 11. So now what we need to do is just figure out what theta is. So we're going to divide 11 by 13.94, and then we're going to take the inverse cosine of that, and that's going to give us an angle of 37.91. So we know this angle right here, which is theta, is 37.91 degrees. Okay. Hopefully that was helpful. Let's move on to cross products. Now, cross products are a little bit more involved, as you can see. Okay, so let's go to a presentation. Let's help you out with that. Okay, go to my little PowerPoint presentation. We just did that. Okay, so cross products of vectors. So cross products of vectors are what you're going to do is you're going to take two vectors, our two vectors again, A and B, both in 3 dimensions, and we're going to multiply them together. What's weird about this is they do result in another vector with a direction. Okay, so if you cross product A times J, you would end up getting a new vector. You'd end up getting a third vector, which is K. It would be, you're essentially taking the perpendicular portions of two vectors, and then when you multiply those two perpendicular portions together, you get a third perpendicular portion. So 1I is perpendicular to 1J. When you multiply those together, you get another vector pointed positive 1 in the K direction or in the Z direction. Okay, so it's kind of weird. It's not as intuitive as I would hope. But there is a method to this. So I'm going to show you, and I'm sure there's lots of ways of doing this, but this is the only way I know how to do this. So what we're going to have to do is we're going to have to multiply these two things together. Now, back in, I think, when you took calculus, we had to multiply, you had to do a little bit of matrix algebra, okay? So what we're going to do is we're going to take, we're going to create a matrix, IJK, which is then the X, Y, and Z portions of A, and X, Y, and Z portions of B. And then we're going to take another extra portion of that. Okay, so again, this is a procedure to get the overall directions, multiplying things by cross product. So what we're going to do is we're going to multiply the I components, which through this line. So the resultant vector would be AY times BZ, and that would be positive in the I direction. And then what we're going to do is we're going to take the Z component of A and the X component of B, so like positive 3 times positive 2, which would be positive 6, but that would now be in the J direction. And we're going to take the I portion of the A vector and the J portion of the B vector, and multiplying those two together, you get the K vector. So we're kind of doing this. But it's not over. Then you have to subtract it from those other portions. So this I portion of that we just figured out, AY times BZ, then we're going to have to subtract it from the other portion, which is going to be AZ times BY. And that is going to make a new portion, which is I hat. Notice that this is the J and K hat directions, and they're creating an I hat. So they're creating the other perpendicular. If you look at this, when we're trying to figure out the J hat, well, then we would only be multiplying the perpendicular portions in the Z and X direction. So, for example, AZ times BX, and then we multiply, then we subtract that from the J portion of AX times BZ, and now we have the J hat direct portion of that C vector. Finally, for K, we're going to go AX times BY minus AY times BX, and that's now the K portion. A little bit more complicated. Okay, but this portion is pretty similar to what we've done before. Now, if you're just figuring out the A and B, if you just knew the sizes of those A and B vectors and you want to figure out the angle between them, you would use sine of theta in this case. So I switched over to my whiteboard again. So again, what we would be doing, just like we did last time, is if we had a vector A, and we knew that was 4, and we multiplied it by vector B, which we know was 5, we would actually end up getting a third vector in the Z direction, which would be 4 times 5, which would be 20 sine of theta, right? Okay, and those angles between them are that angle theta. Okay, we'll get into that in a second, but again, just like we did before, let's figure out what is an actual cross product. Let's practice what we just did. So suppose you had an A vector pointing straight up. A B vector is pointing now up and to the left by -3 in the X direction and up +3. And the C vector is still pointing to the right +2. Okay, so here are the unit vectors. Now, to multiply A times C, well, again, we're multiplying A times C. Well, in this case, we need the perpendicular components of A times C. All right, the dot product will be 0, but the perpendicular components, we could predict what they should look like. Well, A is going to be, again, +4. So that's going to be that'll be +4 only in the J hat direction. And C is going to be, what is that going to be? That is going to be +2 in the I hat direction. Well, when we multiply these two together, since they're perpendicular to each other, we can multiply with cross products. So this will be +2 times 4. So we know the magnitude of the new vector is going to be 8, right? But we know the direction also. Since we're doing an I hat times a J hat, well, the missing vector direction is K, which is the Z direction. So what we're going to be calculating is going to be, will end up being 8K hat. And I don't know the direction if it's going to be positive or negative, but that's how to kind of estimate it. All right, here we go. So let's try this out. In this problem, we're going to have, we're going to multiply, we're going to cross product A and C, which we're going to have to do 4 times 0 minus 0 times 0. So we're going to be doing that first portion. And for the J, we're going to be 2 times 0 minus 0 times 0. And that'll be the J hat. Now the K hat direction is going to be 0 times 0 minus 4 times 0. So that's going to end up actually being in the negative direction. That's really interesting. It kind of reverses. Okay. Let's do A times B. Now, if you look at A times B, again, we're going to try to figure out what the answer should be before we do any math. This B vector, which should be blue, in the y direction, again, is going to be positive 3, right? In the y direction. But the x direction vector is going to be negative 3. So the portion that's going to multiply for A times B is only going to be this vector times this vector. It's only going to be the j portion of A and the I portion of B. So this will be negative 3 times positive 4. So again, I don't know the directions. We kind of have to do a little bit of algebra to figure out whether this is going to end up being positive or negative. But I for sure know the magnitude of the new vector is going to be 12, right? And since this is I and this is j, what we're going to do is that the new vector will be k. So this will be 12k, all right? I don't know if it's going to be positive or negative. I'm suspecting that since both of these were positive and we wound up with a negative, since one of these was negative, we're going to end up with a positive. So, all right, let's try to do it now. So what we're going to do is we're going to create our matrix. So ijk 0, 4, 0. And then for the B vector, we're going to go negative 3 times 3 times 0. And you do have to use the k portions. Since there are no components in the k direction, you still have to write that k direction component. Okay, so what we're going to do, so we're going to go 4 times 0 minus 0 times 3. And that's going to be 0. For the j direction, we're gonna add 0 times negative 3 minus, remember you have to subtract the next portion since these vectors kind of pointing to the leftish. That'll be 0 times 0. Now let's do the k portion. That's going to be 0 times 3 minus a negative 3 times 4 minus 4 times negative 3. So negative 4 times negative 3 is positive 12. I was right in guessing that. All right, finally, let's do this. Let's figure out what is going to be B times C. So B cross C. Well, we need the perpendicular portions. So this is right here. This is positive j, and this portion positive j is perpendicular to this portion of positive 2i. So this is going to be 6, and since it's I and j, the new direction will be k, so it's going to be 6k. Since both of these are positives, well, we're going to wind up with a negative. So I'm thinking the answer should be negative 6k. Now let's try this out. We're going to create our matrix and then our extra portion. So I is going to be 3 times 0 minus 0 times 0. And then we're going to go for the j portion. It'll be 0 times 2 minus 0 times negative 3. It's going to be 0. And for the k portion, we're going to have negative 3 times 0 minus 2 times 3, which will be negative 6. So it works. We can only figure out whether it's going to be positive. We can not only figure out the size of that vector and its direction as being I, j, or k, but we could actually figure out whether it's positive or negative. Okay, let's do a little bit of practice here. Let's try the same problem that we did before, but now what we're going to do is we're going to have to do a cross product of our stuff. And this should say cross product at the top. Cross. I'll fix that in the PowerPoints later. So again, what I want you to do is I want you to start off by writing the vector of the unit vectors of A and B. And what I want you to do is I want you to try to estimate what the answer should be for A cross B. Okay, and we'll just do that right now. So try it out, pause the video now. Okay, well, let's take our components here. And we could do this the math way, but I want to try to estimate what the answer should be. So we know this is going to be, this red guy is going to be positive 2i, and it's going to be up by positive 3j. And we know the other component right here, oops, I should be using blue, for B is going to be positive 4i, and it's going to be up by positive 1j. Okay, so if we multiply the vertical components, my guess is, I don't know what they, so this is going to be, we're going to take the vertical, the perpendicular components, so we're going to take the positive 2i, and then we're going to multiply that by positive 1. So that's what I'm guessing we're going to do. Okay. And the other two components, because we always start with the AX. So you're going to do this portion times this portion, right? Whatever you put first. So in my, I'm imagining my matrix, I'm putting the A vector before the B vector. And then the next portion that's going to be multiplied is going to be the J portion of A, which is going to be positive 3. And then we're going to multiply that so that that's in the y direction times this portion, which is going to be positive 4. So I'm thinking that this, and the end vector is going to be a k hat vector because I times j is always k. So I'm guessing the answer is going to be like 10 k hat, maybe negative. Anyways, let's try it out. So let's set up the vector multiplication part. So it looks like this. And when we multiply it out, what we're going to do for the I hat is going to be 3 times 0 minus 0 times 1. For the j, it's going to be 0 times 4 minus 0 times 0. And for the k, it's going to be 2 times 1 minus 4 times 3. Oh my goodness. I'm right. I was guessing. I was right. I really was guessing. I put this together a long time ago, this slide. So I was right. It works. All right. So now that we know that vector, that C vector, and we know it's pointing in the k direction, and so we know C is pointing in the k direction, and that is going to be negative 10k. All right. Let's go ahead and figure out the angle between A and B in the k direction. So what we're going to do is we're going to do like we did before. We're going to figure out the size of A and the size of B, and we're going to multiply those two together. Okay? And when we do that, we get 2 squared plus 3 squared times 4 squared plus 1 squared, which is going to give us 3.6 times 3.87, like we did before, sine of theta. And again, we know this is going to be equal to negative 10. Okay? Now, 10 divided by 13.94, take the inverse side of both sides, we get 45.84. So the angle between, the smallest angle between A and B is going to be 45.84. Okay? Now, for the tutorials that we're going to do, these can be done really easily if you want. Okay, so the tutorial that goes along with this could be done pretty quickly. And I want you to use whatever method works for you. You could do the mathy method where you're getting into the weeds on it, but let me show you a couple ways to do this. So the X component here, that is pointing to the right by 3, so that's positive 3i, and that's up 3, so that's positive 3j. Now this E vector, which is pointing down and to the right, and just for giggles, what I'm going to do also is I'm going to figure out, you know what, I'm going to stick to what I'm doing. I don't know if we'll need it. So that E vector is pointing down, which it looks like 1, 2, 3, 4. So that's going to be negative 4j. And it's pointing to the right, 1, 2, 3, 4. So positive 4i. Okay. Now that we have it portioned out, let's do the dot product of this. Okay. So we're going to do the dot products, which we had learned to figure out what the length of that third vector right here. To do the dot product, we're just going to take the parallel portions and multiply them together, and then add them to the other parallel portions and multiply them together. So we're going to take, to find Q, we're going to take the parallel the portion right here, which is going to be positive 3i. Q is going to be equal to x dot E, x dot E. So we're doing the dot product first. Okay, so we're going to multiply the parallel portions together. So positive 3i times positive 4i. We're going to add that to positive 3j times negative 4j. And I'm putting the hats there just because I want to make sure I'm accounting for everything. And you do need the negative and positive. That does matter. So Q is going to be equal to 12 plus negative 12. So this is going to end up being 0. Okay. Now, let's do the cross product. Okay. We could do the matrices. We could also try to estimate it. I'm gonna, if we're gonna estimate it, it has to go in order. So I'm gonna put the x direction first. So if I was gonna create the matrix for Q, and I'll show you the reason why I'm thinking this way. I, J, K, then we're going to multiply that by I and J. Okay, so this guy here in the I direction is going to be positive 3, and then positive 3, and then we're going to have a 0, and then positive 3, and then positive 3. Right there. And I don't like the way this 3 looks. Positive 3. For the E guy, for E, what we're going to do is we're going to take positive 4i and negative 4j. not all of these work out as clean as this is going to work out, but okay. So we could do our matrix algebra in a second. And again, what we are doing is we are doing X cross E for this part. X cross E. Okay. Now, since we're going in order, we have to do the, we're going to start with the X direction portion of the red first. So I'm guessing that this is going to be positive 3I. So times a negative 4j. Okay, so that's the first part. Then we're going to have to subtract it from the y direction component of this times the x direction component of this, which is going to be positive. I should use red. And again, I'm only putting the directions in here to keep it in order. Going to be positive 3i, positive 3j, I should say. And then we're going to multiply that by the positive 4j, 4i. So just like we had learned, since you're multiplying i's and j's, your answer is going to end up being k. And I'm sorry this is crooked. So this answer here is going to end up being negative 12. And then positive 3 times positive 4 is also a negative 12. So I'm guessing the answer is going to be negative 24k. I'm hoping the answer is. But we're going to find out. Let's do our little cross multiplication here. So we're going to do this, and this is going to end up being positive, and this is going to end up being positive, and this is going to end up being positive. Now for the j guy, that's going this way, so that's negative. This I will be negative, and this k guy will be negative. Okay, so constructing Q, which is going to be X cross E in this case, we're going to go, for I is going to be positive 3 times 0. So positive 3 times 0. And we're going to subtract that guy. I'm going to do it this way. Positive 3 times 0. And then we're going to be subtracting the other part, which is going to be negative 4 times 0. So 0 times a negative 4. And this will be, since we're doing the I portion, this will be the I portion. Now let's go ahead and add the j portion. The j portion, we're starting out with red. So 0 times positive 4 minus the j portion, which will be positive 3 times 0 times 0. Finally, we got to put our little j portion on here. Now we're going to add that to the k hat portion, which we're going to start out with k is going to be positive 3 times negative 4. minus k hat is going to be positive 3 times positive 4. And this is times the k hat direction. Okay, so what we find out is that this is 0, this is 0, so that q is only going to be due to this portion, which is going to be, just like we predicted, negative 12 times negative 12 k hat, which is going to be negative 24 k hat. Okay? Now, you don't have to do it this way with this vector stuff. You could just do it with estimation like I did right here. Okay? The point is to learn dot products and cross products well. Okay? And this was one of the harder ones to do, so the other ones are much easier. So I'm going to put in my answers for this. This is going to be 0 and negative 24 k. Okay. Well, this concludes our last part of vector review. Okay. So again, please do the reading. It really does help. Thank you very much.